So once I finish lecturing, I'll give this one to you. So you can photocopy and you share. So, right? They just get you things. You can sacrifice. They are just about 1 to 6 pages, 6 papers. So you can just photocopy and share each of the friends.
Yeah, they'll give you the money, no problem.
They'll give you the money. I agree. So let me start. What I'll do, I'll read like this. You guys, if you right? Page 6. That page 6. Yeah, open on page 6. Last week? That was last week?
Yeah, last week.
Huh?
Yeah, last week.
It was last week. Okay. We just do it very fast because this is the area that we covered last week.
How many people?
8. That was it. 59, 70, 71, 72, up to. You have to do a 9. Now just to do is 68, 69, 70, 70, 71, 72, 73. Another page from here. 73. Yeah. fast because you, some people were not there, we are doing this. Alright, we are starting from we are starting from page 68. 68, noted? Or in case 68. You don't have Columbia? Your football?
No.
68. Open page 68. Alright, on page 68, they are talking about the median. They are looking at the median. So you look at the median. The median, by definition, the median is said to be the average that is unaffected by extreme values. That is what is called the median. What it means there, when you look at the median, is the middle number. The middle number is always it's not affected by the extreme number. The median. What they're trying to say there on the median, they are saying is that when you have got the numbers like whichever set of numbers, let's assume we have got 7, 20, 100, 500, and 700. If you look at that one, the middle number from that one is this one. If you look at it, it's this one. The middle number is that one. It's 100, right?
Yeah.
So what they are trying to say is that this middle number is not affected by the extreme values. It is telling us something about these numbers that are there. You can see that they are 500 and 700, right? And here I've got 7 and what? 20. And the middle number is what? 100. What is this telling you? It is telling you nothing. What it is telling you is that it is just the middle number. That is called as the middle number. But it's not affected by this number. Whatever is there, they are not speaking about this number which is just in the middle. You get what I'm saying? So these are what are called extreme values. They are called extreme what? Values. And these are called extreme what? Values. It's not, they are not talking about, it's not talking something about the number of the extreme values there. The median. Alright. If you go to, so they say that the median is an average that is not affected, it's unaffected by the extreme value. It is often described as the middle value. So that is the middle value. If there are two middle values, you add the 2 and divide by 2, right? But again, last time we talked about the quartiles. Right? I said about the quartiles. Q1, Q2, and Q3, right? I said Q1 is lower quartile, right? Which is 25% of the value, right? And if you look at the middle value, which is the Q2, it is the middle value, right? Which is the 50% of the value, right? And as I said, the upper quartile, it is the 75% of the what? Of the value, right? So that I cannot talk about that through the distribution. If you are looking at the distribution, we are saying something like this. I'm just revising what we already looked at. Make sure that each and every time, especially in this class of quantitative, other classes you can miss. But this one, don't miss, because each and every time you miss, it's as good as a man. So, we actually said that it's one quarter, we talk about quarter, is being Q. So we have got Q1, we have got Q1, 2, and we have got Q1, 3. So this one, the Q1 is the lower quartile, which is 25%, and it's just 1/4 of the value, right? It's 1/4, of which we call this one as 25 what? Percent. Di quindi le cavie di qua sono quasi da un professore. Devi chiedere di carico come da luce di voi. Alright. So the Q2 it is the middle what? Quarter, which is the half, right? And this is the 51%. And this one is the other quarter, which is the 3 what? And this is 75.1% of the value, right? It's something like if you are having like a graph of this, right? Math here, math, and here have got the cumulative percentage, right? Cumulative percentage frequency, right? Right? Which if it is percentage, it means 0, 50, and this one is what? 100%. Right? If that is the case, you find the value. So if the graph is of this one, you can find the lower quarter, which is 1/4, right? So 1/4 is 5%, right? So you find 5%, so you can find what is this your Q, this one will be your Q1. Right? So this one, you go to there and you find the value here. This will be your Q1. And this one, the 3/4 is 75 is going to be there, right? So this is the 25, and this one is 71, and you go there and do this, and this one is, the value here is going to be your Q1, Q3. So you can find what is the, you can find the, interquartile range. So find interquartile range is equal to Q3 minus Q1, which is the upper quartile minus lower quartile. So gives you interquartile what? Range. In case you have something like, not cumulative frequency, something like this. In case you have just the cumulative, not percentage, but in case of cumulative frequency here, not cumulative percentage, just a percentage. You have cumulative frequency here, where you have got 0, here you have got 200, and here you have got what? 400. And then your graph is something like this, right? It is ending actually right. It is ending here, assuming it is ending there. So what is find what is Q1 and Q2 and Q3, right? Yeah. So when you find Q1, your Q1 is 400. You are going to find what is this will represent 100%, right? And this will represent 150%, yeah. And this will represent 0%, right? So you will find the 400. What is the 3/4 of 400, right? What is the 3/4 of 400? They are buying 75% of 400, right? So you are going to get that this is 300, right? So where there is 300 here, it's going to be your Q1, Q3, right? Sure. Yeah. Upper quartile. The middle quartile is going to be half of 400, right? So half of 100 is 200. So your quantity. So you go to this one. So this is Q1, 2. You go to your Q3, your Q1. Your Q is going to be 1/4 of 400, which is 100. So you have 100 here. So you go there. And this one is your Q1, 1. To find interquartile range, you do Q3 minus Q1, 1. Right? Let's go to the center. Now, let's go to the center. Right, if you go to the second bullet is down there where they are looking at the 8th percentile. The right? So the n percentile is represented as this is that's the n percentile is 10, of which is the value 8% of the weight of the distribution. This is the value of n% of the distribution. That is the value of n% of the distribution. Sorry, when I'm doing like this one, I don't have glasses. For me to see properly, I have to not to say but I'm just doing it. So now, you get what I'm saying, right? So we're talking about the 8%, we're talking about percentile. Percentile is this one. When I say P20, what does that mean? This means it's 20 what? Percent. Is that it? Right? When you talk about, because your end is this one. The end, right? 70 percentile. 70% is the same as the P70, right? Which is the same as the 71%. You get that? Well, we're done from there. Let's go to interpercentile range. Range becomes various percentiles can be found. For example, the range giving the needle, which is 80% of the reading, is subtracting the 10% from the 90%, which it is P90 minus P10. When finding the median and the percentile, it is important to take note of whether the data are grouped or they are not grouped. I think I'll come back to the percentile. We'll consider the percentile. Let's just reserve a little on percentile. I'll come back to that percentile. Right? Can you switch off a little from that one? I will come back to that element of percentile. Because I want you to understand this element, what I'm trying to make here. Let's go to ungrouped data, median. Let's go to ungrouped data. You know what is ungrouped data? You have grouped data. You know what is grouped data? Grouped data is continuous data. The other is in the range, grouped data. But ungrouped is like 1, 2, 3, 4, right? Where I see the little spot in the median, right? Assume, let's go to that one. Consider the set of numbers like 7, 7, 2, 3, 4, 2, 7, 9, and 31. Have you seen that? Let's find the median. How many numbers are there? 9. There are 9 numbers, right? So your numbers, there are 9. What is the median there? If it is 9 numbers, which number is it? The best thing, what do you do? How do you find median? You have to arrange them in what? In order. Good. Very good. Arrange them in order. If you arrange them in order, they have arranged that number in order. So they are saying that the median is what? 7. Simple, because you can count the middle number, right? 6. The formula they are giving us to find the median, to find the middle number, it is n plus 1, half n plus 1. So they are saying there are 9 numbers. So the median is half n plus 1. So to find that one, the formula is half bracket n plus 1. Half bracket n plus 1. Find the median. So it is half. A is how many numbers? 9. Plus 1, 10, right? So half of 10, 5. So the number 5 was 1, 2, 3, 4, 5. The one that Get that?
Yeah.
Good. If you don't understand, you cannot get understanding theory. Let's go to the other one. Consider the state of generalization. Have you seen that one? How many numbers are there? 8 numbers. So first of all, you have to arrange them in order, right? So arrange them in order. So they have arranged it down in order. Right? If you use that formula here, let's use this formula. You are saying there are how many numbers? 8. Let's use this formula. Remember, this data is an group data. It's not good. So it is half 8 plus what? 1. Which is the half of 9, right? Which half of 9 is what? 4.1? 4.5. It means we count numbers 1, 2, 3, 4. Right? There must be 2 numbers. If you look at that one, it is 4. 4.5 compensation. So you find the value of between 4 and 5. So you count 1, 2, 3, 4. So the value you did 4.5. With at the middle of, when you count how many numbers? 1, 2, 3, 4. After 4, at the middle is where you are getting that one. Right? So you add the 2 numbers and divide by 2. Right? That's what they have done there. Clear? Let's go to another one. Right? Let's go to therefore the formula there says about this is the ungrouped data. For you to find the median, the formula is this one, or just a half bracket C plus D. Where you will see is I think let me just use this. Let's look at ungrouped data. Let's use the ungrouped data. Quantitative. Let's go to quantitative. Median is very simple because median, if it is one number, you can support that one, right? If there are 2 numbers, add the 2 numbers, divide by 2. But now let's look at the quantitative. Let's go back to the quantitative. So there, I will ask you to think. You need to think. You're doing it very fast. Group data quantitative. Group data quantitative. The quantitative will divide. What are they saying?
Which is now? This one is ungrouped.
Ungrouped data. Ungrouped data is to us. 69. Is that?
Yeah, it says grouped, so I didn't.
No, ungrouped. Ungrouped, sure. Ungrouped data pattern. Right? Let's consider the first one, the first set of numbers. Then the 3, 5, 6, 8, 9, 12, 14, 19, 20, 24. And just tell me the numbers and I can write them on this. I can write them and you can discuss.
3,
Right? 3, 5, 6, what? 8, 9, 12, 14, 19, 20. 24. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Is 11 odd number or even number? Odd number. An odd number is a number that cannot be divided by. Therefore, 11 is an odd number. It's simple for you to find the median when you are using odd number. Odd number, simple. Because you are divided by 2 odd numbers, if you have to remember. So you have to have, there are 11 numbers, yes? There are 11 numbers. Therefore, the median is be which one? 1, 2, 3, 4, 5. This one will be the median here. Yes? This one.
Yeah.
Right? Here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Median here. Clear? Which is this one? It is your quarter. Because we are looking at quarter here. This is the third quarter, which is the fifth. It's a Q1. Q2. Right?
Yeah.
This is our Q2. Q2. Middle quarter. Let's find Q1. Let's find Q3 from this one. Right? Look at these numbers. Right? Look at these numbers. How many numbers are there compared with? 5. So, you know, which one is your quarter number? Because let's talk about Q1. We are looking at Q1, it's the 75% of the number. Q1, it is a quarter. So, which one is your quarter? 25% of the number. That is your quarter. Let's go to this one. In other words, from this one, if this is half of this one, it is your Q1. Right? So what is half of this? This one is your Q1. Right? Go to the other side. Half of this side here is your Q3. Which one is that one? 19. This is your Q3. Is that? Yes? So because in Japan already, you are taking this one minus this one. It is 19 minus 5. Right?
Yeah.
Clear?
Yeah.
Example 1 is that. You cannot talk about further. Let's go to example 2. I tell you, last Sunday, the dead boys are dead. We had to struggle with the weekend for them to understand this, what we're doing. It took us 1 hour. We went in up to 5 o'clock. 35. Sound. We are not understanding what we are doing. Now, let's look at another one. Let's look at another one. You will see what they are trying. Let's go to the second one. Give me the number for the second one. 20, 23, 23, 26, 27, 28. How many numbers are there? 6 numbers. So which one is your median? Which one is your Q2? Q2 has to be here, in between here. Right?
Yeah.
Q2. Is that?
Yeah.
Hey?
23 plus 26 is 18.
It's going to be this one, this one, it's going to be right? Which one will be your? So if you look at this is your, this one is your Q1, Q2. The one is your Q1. Q1, it is the middle number. How many numbers are here? So the middle number here is your Q1. Q1. Go to the other side here. Which one is your Q3? 27 is your Q3. Do you understand what I'm saying? Huh?
Yes.
Okay, good. Let's go to. So, I cannot talk about here. You just take this one divided by 2, right? We start. Let's go to another example. The other one. You get what I'm saying? What do I do? If you are lost, ask your friend. Let's go to another example. We'll go up to. Let's go to another example. And this example is this one, which is Give me the number. You see, for complication. Numbers. 147, 150, 154, 158, 159, 160, 165. Right. Let's find the Q1, Q2, Q3. Q1, Q2, Q3. How many numbers are there? Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Right? Yeah. So your Q1 it has to be here. Hey? It has to be here. Q1, 2. What is your Q1? Q1, you are counting again numbers. 1, 2, 3, 4. It has to be here. Right? This is your Q1? Q1. What is your Q3? 1, 2, 3, 4. It has to be here. Q1? 3. Next? It's done. Right? Let's go to this where. Let's go to the other one. If that is there, let's go to another one. And then we can. The other one. 10, 12, 13, 15, 19, 24.
There are 219.
Oh, there are 219. So good. 24, 26, 26. Remember to put numbers in order, right? These are already being arranged in order. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Which one is your Q2?
19.
The first 9 is this one. This one is your Q1, 2. Simple for that, right? Yeah. Let's find our Q1. What will be our Q1?
Between 4 and 6.
It's going to be between 12 and
15.
because there are 4 numbers, so it's going to be. So here it's going to be your Q1. Let's find the Q3. It's just going to be here. Q3. Is that? Right? Then, it's done about that. Let's go to. Take the phone, skewed in it. Are you there? Not yet. Go to it. Oh, this was the time too, but we should make it. You're supposed to have retail control. Right? Supposed to be retail control. So, this one, here, quantitative. Oh, yeah, yeah. 1, 2, 3.
Ndio movement ifuni very serious.
This one was saying skewed in it. What is the meaning of skewed? Can you check from your dictionary, from your review, what is the meaning of skewed? What is the meaning of skewed? Check from your
Suddenly change direction of position.
yeah?
Sudden change direction of position.
Sudden change of direction of
Or position.
or position. Sudden change of direction or position. Just be on your 84 page. There are three major known types of skewing in quantitative techniques. There are three main types of skewing in quantitative techniques. Sudden change, a sudden change in direction. So we have got positive skewed, where the tail points to the positive direction. We have got the negative skewed, where the tail points to the negative direction. And we have got the symmetrical skewed, which is sometimes known as the normal skewed or normal distribution. So we've got three. Oh, page, are you there on page 4?
Yes.
So they are saying we have got negative skewed. If you got negative skewed, the tail points that negative direction. Have you seen that one? Then we have got that one, which is symmetrical skewed, which is known as normal skewed. Normal skewed. It means it's just not normal, right? We have got the other one, which is positive skewed. The tail points in the positive direction, right? You remember about this you can remind you when you drew two graphs, you couldn't find who scored the right mark until you came up with what is known as you came up with the density. You remember what? My word. So until you came up with the density, it's when you can know how this is the tail point to this one or that one. Right? Right. If you look at let me just explain a little about this. The meaning. It has this meaning. Like let me just suppose I have this. What is this one? Positive skewed. Because it's going to the positive direction, right? Positive skewed. Positive. What is it? Negative. What is this? It's negative. Right? Right. Let me tell you this.
The word symmetrical, we miss it on example, we just say normal.
It's a norm. It's a norm. This is a norm. No. It's a norm. Sometimes it's not symmetrical. It's normal. Right? Now, where last time when I had these two here, I actually said in a normal situation, this and this one, you can take it at 95%, which is 0.05. Again, here you can take this one 95% confidence interval. When this is where I actually say talk about this, which is this side 0.5, this one 0.5 is the same. So this is just symmetric. Where more the median is actually the same, because this is the middle. This comes to this one. What does that mean? Here, if this is a graph, right? Positive skew. What does that mean? A lot of students here, they have failed the exam. Here, they have failed here. That's why I have that. If you look at this situation where you have got that one, the median is all that the center. Look here, I've got 1, 2 lines and 3. How many lines are here? 3. Right? Yeah. This is the real median. Median is the real number, right? The first one after that median, we look at the first one is your mean. This one is your mean here. If this is the mean, this is the median, this will be your mode. What does that mean? Mean here, when you calculate your mean, if you have got distribution, the numbers, and you calculate your mean, and you find that your mean is small, and you calculate your mode, and you find that your median, and you find that your median is that like that, and you calculate your mode, and you find that your mode is the biggest of all, then this situation what? It means a lot of students have failed the exam. You calculate your mean, assuming that your mean is the 5. Your mean is 5. And your median, assuming that your median is 7. And assuming that your mode is 12. This situation what? Because your mean is smaller than the rest of this one. The median still be at the middle. So when the mean is less than median, is less than mode, of which in this situation here, mode is greater than the rest. This situation holds. It means it is positively skewed. So this is positive what? Positive skewed. Positive skewed mean is very small here. See, mean is here. Now let's come to negative skewed. Negative skewed, look at this one. This is your graph here. If you look at that one, numbers that are here, 0, 1, 2, 3, if it is a match, it means a lot of people, they have passed here, right? Because the match are here, they are born here, right? So a lot of them, they are passed. A lot of them, they are passed. The exam here was easy. This is an easy exam. You know that? It's an easy exam here. A lot of them passed. But this was the what? Difficult exam. Right? Now, if you look at this one, the fact that this is an easy exam, you get what I'm together here. If you get this one, this is an easy exam. What does that mean? There will be 3 lines again here. There will be 3 lines here again. The center one, the median should be at the middle here. Median is there. Right? But if you look at this one is this one is the mean, right? So this mean here is going to be here at the end here. And if this is the mean, this is the median, what will be this one? Mode. What does that mean? Mode is greater. When you calculate your mathematics and you find that mode is greater, and mode is smaller, but the mean is greater, this scenario holds. The example was that I will write this example. I can give you like a distribution like, let me just give you this distribution. 7, 9, 12, 15, 20. 20. Suppose we are presenting this one and find whether it is positive skewed, negative skewed, or it is the... Let's look at this one. What is your median? Median is this one, right? 15, eh? Median is 15. Is it? Middle number is 15. Median. Huh? All right. Between this and that. So what is your median? What is the median? I is the 2. It's going to be what? Yeah. When 7 divided by 2. 30.5. 30.5 median. What is your mode? Number of the mode? 20. Mode equals to 20. What is your mean? Add the number divided by how much there? Add. What is your mean? Huh? What? 13.8. Alright. 13.8. Which graph? Between this and that one, the skewness, which one? Where mode is great? Where mode is greater than mean, it is positive. Where mode is greater than mean, it is positive skewed here. If it is an exam, was it a difficult exam or an easy exam? It was a difficult what? Exam. If you are looking at this in this way, you must have done it. You understand? Let's come to this situation here. What does that mean? In a normal distribution, that is what's called normal distribution. This is a skewed, it's a negative skewed. If you in a normal distribution, this is a normal distribution. It is where mean is there, mode is there, median is there. When the mean is equal to mode is equal to median, the answer then becomes the normal distribution. That's what means that the exam was that the meaning. When the mean, if the mean is 20, mode is 20, median is 20, that means that is the normal one. Sometimes it can't be actually being 20, but it can just close. It's just approximation. When you mean you are when you mean is a big approximation, you mean more like that. If it is something like when you are it's just close to that. This situation holds. When in a normal situation where there is a tail there, this side here and this side here, they are just symmetrical. And the mean mode median is just the mean. And when you are testing, you can test this at 95%. This one you test and that one 95. 95, means 0.05, 0.05. Because what I'm trying to say, if this is 95, this is 90. What from 95, from 100%, what is remaining? 5, eh? So 5%. Now, what is 5%? 25% into this. 0.01. Fine. That's what I'm saying. That I think this is 0.01. Fine. Well, 0.05 is 5% to 25%. Because from here to here, it's 100%. So the 95% is coming because what I'm saying is this one. 95% is coming because all this, it can be 95 what? 95%. Now if this is 95%, the whole of this is 95%. What is the remaining there is what? 5 what? 5%. So 5% is the 0.01. But again here is 0.01. Fine. Because the whole of this one is 95%. Let's go back to what was key. Right? Open on the other side. Then, this is taking us to another level. Now, it is taking us to another level. And this level, what we are looking at now, it is the Pearson coefficient of skewness. Let me talk about Pearson coefficient of skewness. I'm ready to do this. Yes? Yes. Kwa hiyo tunajikuta kwanza ngoko na jifunza ndipo for them to understand this sana ndio the sana jambo tu ngamo pale bila gani katola. Oh, that's what it is. The Bible says the very same thing that no, they can be one can be seen, but not a level to follow. Let's look at now the Pearson. The Pearson coefficient of skewness. You know, there was a gentleman known by the name of Pearson. Pearson is the one who discovered a certain theory, and he called this theory a Pearson coefficient of skewness. You can come up with your theory. Now, what Pearson did, he came up with this issue here. Pearson, if you go to page 85, notice that when the distribution are skewed, the median generalizes between the mode and the median. Always when the distribution is skewed, the middle number is still there. You cannot change. Right? When the numbers are skewed, Serena will be there to the middle. But what will be changing is you and can be that one. The mean or the mode. The mode can be there, the median can be there, or the median can be there, the mode can be there. But this one at the middle will still be there. You get what I'm saying? What is making you to know that this is skewed is the tail. Where is the tail going? Hey, sometimes for this tail, what it means is this one. What it means? Because you have to know what it means this one. If this is your graph, assuming this is your graph, right? Assuming this is your graph, you can have something like that, this point here, right? You can discover that these points are going into this one. They are going there, they are going there, they are going there, they are going there. Have you seen that? Where is it skewed? Is it positive skewed or negative skewed? When you connect this positive, it's positive. Right? So, the skewness are the points. Now, what is that to say? He actually came up with this thing here. He actually said, Pearson said, when you take mean minus mode, Pearson said, when you take mean, let's just say, there are Pearson distribution. Pearson coefficient. I like this in an exam. Pearson coefficient distribution. I like this one. Pearson coefficient. Now, what Pearson says, we get mean minus mode is the same as, it's not the same, but it is equivalent. To be equivalent. It's equivalent to, what is it? 3 open bracket mean minus median. 3 open bracket mean minus median. Yes, came out with that. Now, look what this was. This is not equal. Right? If I take Selena and the Yvonne, I take Selena and Yvonne. Are they the same? Is Selena and Yvonne the same?
No.
When you see Yvonne, you can say, well, they are not the same, but they are equivalent. Right? What is making them equivalent? Because they both are related. Right? The features that this one is having, she's having the present feature. So therefore, because of that, she's equivalent. They are not the same. Right? They are equivalent. That's what it means. Now, what does that mean? What it means here is when you get mean minus mode, it's equivalent to, when you get the answer, when you work out mean, you subtract mode. When you calculate mean and you find mode and you subtract, there's a distribution. This is my mean. This is my mode. You when you subtract rather and you weigh the median, you multiply 3 times. You set the mean minus the median multiplied by 3. You will discover that the answer will not be the same, but you just be close to that. Can we try? Let's come up with a distribution. Okay, funny distribution. Choose your own distribution where you have a mean, mode, median, and factor. And if I calculate mean, mode, median, then we subtract and find out what the answer we are going to come up. Right? So 4, 4, 6, 8 what? 10. 12, 14. 12, 14. Where's the list to the one? Put us at the mode. Right? When you work out mean, let's find out mean. Mode, our mode is what? Mode is 6. Mean you can find. What is our median? What is our median? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 1, 2, 3, 4. So, it's 6. I is the 2 divided by 2, right? Find the mean. What? 7.2. Let's come up with